What is a multiple? Multiple of a number is formed by multiplying that number by another whole number or counting numbers like 1, 2, 3, 4, 5, etc. For example, write the first 10 multiples of 3. Remember the table of 3? The number 3, 6, 9, 12, 15, 18, 21, 24, 27, 30 are all the first 10 multiples of 3. Remember, if we multiply any number by 1, 2, 3, 4, 5, we get the multiple of that number. Example 6. Write the first 7 multiples of 6. To find the multiples of 6, multiply 6 by 1, 2, 3, 4, 5, 6, 7. The numbers 6, 12, 18, 24, 30, 36, 42 are the first 7 multiples of 6. Remember, the multiple of a number is either greater than or equal to the number. There is a relation between factors and multiple. We have studied in factors that 8 into 3 is equal to 24, where numbers 8 and 3 are known as the factors of 24 and the number 24 is known as the multiple of 8 and 3. When we multiply 2 or more numbers, we get their product, which is the multiple of each of the numbers or factors multiplied. Example 7. What is 9th multiple of 5? Solution. There are 2 ways, long way and short way. Or simply 9 into 5 is equal to 45 or 5 into 9 is equal to 45. Remember, the multiples of even numbers are even numbers, whereas the multiples of odd numbers are even and odd numbers alternatively. Write one table of even number and a table of odd number. You will find the answer. Example 8. Is 64 a multiple of 8? Solution. To check whether 64 is a multiple of 8, simply divide 64 by 8. We find that 8 completely divides 64, leaving no remainder. Therefore, 64 is a multiple of 8. Example 9. From the numbers given below, circle all the multiples of 4. Solution. Check which of these numbers are divisible by 4 completely, leaving no remainder. We get 16, 24, 36, 32, 48, 4, 88, 64, which are completely divisible by 4. Therefore, these numbers are the multiples of 4. Study the following table of numbers and their multiples up to 13. Multiples. Some facts about multiples. Every number is a multiple of 1. For example, 4 is a multiple of 1. 4 into 1 is equal to 4. 7 is a multiple of 1. 7 into 1 is equal to 7. Every number is a multiple of itself. For example, 3 is a multiple of 3. 3 into 1 is equal to 3. 12 is a multiple of 12. 12 into 1 is equal to 12. 0 is a multiple of every number. For example, 0 into 5 is equal to 0. 0 into 9 is equal to 0. There is no limit to multiples of a number. They are infinite. For example, multiples of 3. 3, 6, 9, 12, 15, 30, 33, 36, 39, 42, 54, 57. It goes till infinity. Every multiple except 0 is either equal to or greater than the number itself. Here, 5. 10 is greater than 5. 15 is greater than 5. 20 is greater than 5. 25 is greater than 5. The product of two or more factors is the multiple of each factor. For example, 7 into 5 is equal to 35. Here, 35 is the multiple of 7 and 5 both. Common multiples and least common multiple, LCM. The least common multiple, LCM, of two numbers is the smallest number, non-zero, that is a multiple of both. Let us take two numbers, say 3 and 5. Now, find the multiples of both the numbers. Multiples of 3. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. Multiples of 5. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. Circle the common multiples of both. Common multiples are 15 and 30. We can get more common multiples if the list continues. Among these common multiples, which is the least common multiple? Yes, it is 15. Therefore, 15 is the LCM of numbers 3 and 5. The LCM 15 is exactly divisible by the numbers 3 and 5 separately. Remember, the LCM of two or more numbers cannot be less than any one of the number. Example 10. Find the common multiples and LCM of 4 and 6. Solution. Multiples of 4. 4, 8, 12, 16, 20, 24, 28. Multiples of 6. 6, 12, 18, 24, 30, 36, 42. Circle the common multiples. Common multiples are 12 and 24. The least common multiple, that is, LCM, is 12. Example 11. Write the common multiples and find the LCM of 5, 6 and 15. Solution. Multiples of 5, 5, 10, 15, 20, 25, 30, 35, 40. Multiples of 6, 6, 12, 18, 24, 30, 36, 42, 48. Multiples of 15, 15, 30, 45, 60, 75, 90, 105. Circle the common multiples. We find 30 is the common multiple and also the least. Therefore, LCM of 5, 6 and 15 is 30. Example 12. Find the LCM and HCF of 9 and 81. Here, solution. Here, 9 is the smaller number and 81 is the larger number. Now divide 81 by 9. There is no remainder left. Therefore, HCF is equal to 9 and LCM is equal to 81. Remember, if one number is the factor of another number, then their HCF is the smaller number itself and LCM is the larger number itself. Tests of divisibility. Divisibility means that you are able to divide a number evenly without actually performing division. Divisibility rules of whole numbers are very useful because they help us to quickly determine if a number can be divided by 2, 3, 5, 10, etc. without doing actual division. When the numbers are large, use the following divisibility rules. Remember, tests of divisibility help in finding factors. Rule 1. Divisibility by 2. A number is divisible by 2 if its last digit, that is, the digit at ones place, is 0, 2, 4, 6, 8. For example, 934. The digits at ones place is 4. Therefore, 934 is divisible by 2. 1830. Divisible by 2 as 0 is at ones place. 4353. Not divisible by 2. the digit at one's place is not 0, 2, 4, 6 or 8. Rule 2. Divisibility by 3. A number is divisible by 3 if the sum of its digits is divisible by 3. For example, 1314. Sum is 1 plus 3 plus 1 plus 4 is equal to 9, which is divisible by 3. So the number 1314 is divisible by 3. 3201. Sum is 3 plus 2 plus 0 plus 1 is equal to 6, which is divisible by 3. So the number 3201 is divisible by 3. Rule 3. Divisibility by 4. A number is divisible by 4 if it is even and can be divided by 2 twice. For example, 856. Half of it is 428 and 428 is still divisible by 2. So 856 is divisible by 4. Rule 4. Divisibility by 5. A number is divisible by 5 if the digit at one's place is 0 or 5. For example, 6205. Digit at one's place is 5, so the number 6205 is divisible by 5. 9320. Digit at one's place is 0, so the number 9320 is divisible by 5. 9344. Not divisible by 5 as the digit at one's place is neither 0 nor 5. Rule 5. Divisibility by 9. A number is divisible by 9 if the sum of the digits adds up to a multiple of 9. This rule is similar to the divisibility rule by 3. For example, 5634. Sum of digits is 5 plus 6 plus 3 plus 4 is equal to 18, which is a multiple of 9. So 5634 is divisible by 9. Rule 6. Divisibility by 10. A number is divisible by 10 if the digit at one's place is 0. For example, 6320. Divisible by 10 as the digit at one's place is 0. 9300. Divisible by 10 as the digit at one's place is 0. 4393. Not divisible by 10 as the digit at one's place is not 0. Check the divisibility of the following numbers: 2, 3, 4, 5 and 9. 2, 3, 4, 5, 9 and 10 by putting for yes, tick, cross for no. Prime and composite numbers. Numbers that have only two factors, that is 1 and the number itself, are called the prime numbers. We can also say that number that is divisible by only 1 and itself are called prime numbers. For example, number 2. Factors of 2 are 1 and 2. Number 3. Factors of 3 are 1 and 3. Number 5. Factors of 5 are 1 and 5. Number 7. Factors of 7 are 1 and 7. Number 6. Factors of 6 are 1, 2, 3 and 6. Number 6 is not a prime number. Then what kind of a number is number 6? It is a composite number. Composite number. Numbers that have more than two factors are called composite numbers. Number 6. 1, 2, 3 and 6 are the factors. There are more than two, so number 6 is a composite number. Number 9. Factors are 1, 3, 9. So, 9 is also a composite number. Remember, number 2 is the smallest and the only even prime number. 4 is the smallest composite number. Remember, number 1 is neither a prime number nor a composite number because it has only one factor, which is 1. It is called a unique number or a special number. Twin primes. A pair of prime numbers that differ by 2 and these numbers have composite number in between. For example, 5 and 7, 11 and 13, 17 and 19. Co-prime numbers. A pair of numbers not having any common factor other than 1 are called the co-prime numbers. For example, 5 and 9. Factor of 5, 1, 5. Factor of 9, 1, 3, 9. The factors of 5 and 9 are not in common except 1. So, 5 and 9 are co-prime numbers. 15 and 16. Factors of 15. 1, 3, 5, 15. Factors of 16. 1, 2, 4, 8, 16. The factors of 15 and 16 are not in common except 1. So 15 and 16 are co-prime numbers. Remember, the HCF of two co-prime numbers is 1 and LCM is their product. Method to find prime numbers from 1 to 100. The Greek Eratosthenes created a method to find prime numbers, although it worked only over a limited range. It was known as the sieve of Eratosthenes, which sieves the prime numbers from composite numbers. Write numbers 1 to 100 as shown. Make two parallel lines to cross out 1 because 1 is neither a prime number nor a composite number. Encircle 2 and cross out all the multiples of 2 other than 2 itself. Now move to the next number, which is number 3. Encircle number 3 and cross all the multiples of 3. Next uncut number is number 5. Encircle number 5 and cross all the multiples of 5. Next number is 7. Encircle number 7 and cross all the multiples of 7. Continue this till the numbers are encircled or crossed out in the given list from 1 to 100. We find that all the encircled numbers are prime numbers and all the cross numbers other than 1 are the composite numbers. Note, the only even prime number is number 2 and it is also the smallest prime number. The list of prime numbers between 1 to 100 are 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, 71, 73, 79, 83, 89, 97. Smallest prime number 2. Smallest composite number 4. Example 13. Which of the following numbers are prime or composite numbers? 12, 19, 25, 31. Solution. Factors of 12. 1, 2, 3, 4, 6, 12. It is having more than 2 factors, so 12 is a composite number. Factors of 19. 1, 19. It is a prime number because it has only 2 factors. Factors of 25. 1, 5, 25. It is a composite number as there are more than 2 factors. Factors of 31. 1, 31. It is a prime number because it has only 2 factors. Prime factorization. When a composite number is written as a product of all its prime factors, we have the prime factorization of the number. We can perform prime factorization by a factor tree method. A factor tree is a handy way to factor numbers to their prime factors. The factor tree starts at the root and grows upside down. Example 14. Find prime factorization of 36 by factor tree. 36. Composite. 18. Still composite, factorize again. 9. Still composite, factorize again. 3. Prime. 2. Prime. Steps to factor tree method. We know that 36 is a composite number. Divide 36 by the smallest prime number, which is 2. 36 divided by 2 is equal to 18. 18 is also a composite number. Divide it further by the smallest prime number, 2. 18 divided by 2 is equal to 9. 9 is a composite number, which is an odd number. So divide by next prime number, say 3. 9 divided by 3 is equal to 3. We get 3 and 3. Therefore, the prime factors of 36 are 2 into 2 into 3 into 3. Example 15. Find prime factors of 18 by factor tree method. The prime factors of 18 are 2 into 3 into 3. Test yourself. Fill in the blanks. Recall properties of division. Fill in the blanks. Recall properties of division. Fill in the blanks. Recall properties of division. Complete the patterns in numbers. Complete the patterns in numbers.